Hello and welcome back, and if you are new here, welcome. We are very glad to have you here. Today, instead of usual intro into video topic, we find ourselves singing same tune, the whole day, and tune goes something like this. Here we go again. From the thumbnail, and as well as from video description, you might have guessed that today on the menu we have another example of bad naming scheme in electronic, but to add insult to injury, today we have a special, we also have bad design, as well. No escape from this conundrum, so let's dive deep, head first, and hope we do not regret it. First order of the business today is to dispatch with good design of NPN symbol. You have learned from previous videos that this is symbol for NPN transistor. It can be drawn with, or without circle. Our choice is to draw the symbol with the circle, as this is how the symbol is drawn by the manufacturer of the component. Three terminals are called, from top, counterclockwise, collector, base and emitter. The arrow is pointing out of the emitter, depicting the flow of current out of the transistor, through the emitter terminal. It also depicts the direction of current going into the base terminal. Depending on the chosen function for NPN transistor in the circuit, there are also a couple of resistors, and a power source. In general, this is the basic schematic for NPN transistor. In case you use NPN transistor as an amplifier, there are also a couple more capacitors, and additional resistors, but for now, this is good enough. In episode 8, we have learned the difference between conventional, or as it is also called, engineering, direction of flow of current, and natural or electron direction of flow of current. Now we also know that this is convention, an agreement, to consider holes, the positive carriers, as the facilitators of propagation of electromagnetic field through the circuit. Simply put, the current flows from positive to negative terminal of DC power source. For NPN transistor, the collector sources the current from the battery. There is also a limiting resistor RC, sometimes it's called the load, limiting the amount of current going into transistor. Next, we have a base, where amount of current in the base terminal, regulated by RB resistor, determines the function of the NPN transistor. In the transistor, collector and base current adds together, and flow out of transistor through emitter terminal. Simply put, emitter current is sum of collector and base current. And that, in a nutshell, is a NPN transistor for you. The animation shows the flow and direction of current through all. We could only wish that PNP transistors were this straightforward. Our job would be much easier, but nothing is to be gained from complaining, so let's get into the mud with PNP symbols and transistors. Usually, the PNP transistors are explained as follows, everything exactly the same as with NPN transistor, but just the opposite. Flip the symbol, and change the direction of currents, and there you have it, an expert in PNP transistors. What kind of crappy explanation is that? The confusion with PNP transistors comes from that unfortunate symbol, an arrow pointing in all wrong directions. And to top it all, the PNP transistor is often flipped in schematics, making the confusion even worse. Let's untangle this mess. The PNP symbol is often represented in two versions. First version, on the left-hand side on the screen, is analogous to NPN symbol, but this time, the difference is where the O at the emitter terminal points. For PNP transistor, the arrow points into emitter terminal. Okay, so no big deal. We pay close attention to emitter arrow and we are all good. But wait, there is the second version of PNP transistor symbol, the one on the right-hand side of the screen, one that is flipped horizontally, so that now, the emitter is on the top, and the collector is at the bottom of the symbol. Luckily for us, the emitter arrow still points into the emitter, so that is one good thing. Also, the symbols can be drawn with or without circles, but to simplify things, we will discuss symbols with circles, like in datasheet from the manufacturer of the component. Now, the terminals are also flipped, so on the left-hand side we have, from top, counterclockwise, collector, base and emitter, and on the right-hand side, we have, in same direction, emitter, base and collector. Also, for PNP transistor, the base current comes out as a part of collector current, and exits the transistor, through the base terminal. What a mess, everything is jumbled and lopsided. But wait, it gets worse. Now, let's draw up a schematic of a simple circuit with PNP transistor. Depending on the chosen function for PNP transistor in the circuit, there are a couple of resistors, and a power source. In general, this is the basic schematic for PNP transistor. In case you use PNP transistor as an amplifier, there are also a couple more capacitors, and additional resistors, but for now, this is good enough. For PNP transistor, we will also adopt the conventional or engineering direction of flow of current, from positive to negative terminal of DC source. But now, things are looking a little bit different than from the before. What's the same is that, collector still sources the current from positive terminal of the battery, and that current goes into the PNP transistor. Also notice, that there is no collector current limiting resistor anymore. When collector current enters the transistor, it splits into two streams, base and emitter current. The base current exits the transistor through the base terminal and sinks into negative terminal of battery. The remaining current exits the transistor through the emitter terminal. This current is regulated by the RE resistor, sometimes also referred as a load. If you want the same schematics, but with flipped version of symbol for PNP transistor, there it is. The flow of currents is the same, only the symbol for PNP transistor is flipped horizontally. It would be prudent to abandon looking for symmetries between schematics for PNP and NPN transistors. They can be very confusing and misleading. Although they have similarities, it would be very prudent to distinguish between them, and treat them as separate components, because they are. The primary reason for varying the orientation is to get clearer and more readable schematics. Engineers and designers will orient the symbol to minimize crossing lines and simplify the overall flow of the circuit diagram. So, this is all just for aesthetics. From this point forward, and in future videos, we will adopt symbol for PNP transistor that has the same orientation of terminals as the NPN transistor. You are of course, absolutely free to make different choice, but the point is to be consistent in your designs and implementations. Now, let's see how and where current flows in PNP transistor circuit. Adopting the conventional direction of flow of current, for PNP transistor, the collector sources, or simply said, draws current from positive terminal of the battery. The current enters the transistor and there it splits into two streams. One part exits transistor through the base terminal, while other part exits through emitter terminal. So, in PNP transistor, the remaining emitter current is what is left when you subtract base from collector current. Unlike the NPN transistor, for PNP transistor, the direction of emitter current is the opposite direction than the one that the emitter arrow is pointing. For PNP transistor, the emitter arrow points in the direction of base current. In order to make sense out of this whole mess, the most efficient and effective way to remember symbols and orientations is to remember the direction of flow of base current. For NPN transistor, the base current flows into the transistor and follows the direction of emitter arrow. For PNP transistor, the base current follows the direction of the emitter arrow and exits the transistor. This is the simplest way to remember how to differentiate both types of transistors. Now, whatever orientation of PNP symbol you choose to adopt, the imperative is on consistency. Please, before you leave, show your appreciation by liking this video, sharing it, leaving a comment, and consider subscribing. Thank you, and see you next time. Bye.